Hello guys and welcome back. So now I wanted to talk about the pyro solver and explain how it works and what its purpose is. And so far all the sims that we've been creating are done using the smoke solver. And no matter how much smoke or density we're going to emit, we don't have anything that looks like an explosion. We have every time we do a sim, it looks like a smoke sim. There is no explosiveness to it. There is no fire or any expansion. And I wanted to show this video of an actual explosion, and we're going to analyze a couple of frames. So this is a missile that can detect the location of the tank, and then once it reaches that, it explodes. So you can see it flying here. This is the missile, and then once it reaches that location, it's going to explode. Now let's analyze these frames carefully. Let's take a look at the second reference, and then we'll go back and analyze that. Okay, so what if we step frame by frame on this? You can see that from frame 14 to frame 14, there's this entire change. There's a huge amount of change in a fraction of a second. The camera is not able to capture that. It takes less than one frame, and it takes less than 1 millisecond to actually for this reaction to happen. And it's a huge chemical reaction that causes a lot of expansion, and it causes a shock wave. It distorts the atmosphere. You can see it around here. That's how fast the expansion is, and then it continues, and the chemical reaction continues. Probably the tank is exploding itself, and then from this frame into this frame, we can see a huge change in the amount of fire and smoke we have. And then if we continue, it's going to keep expanding until it consumes all the fire or all the chemical that is burning and reacting, and then it decays. The temperature decays and becomes smoke. And this type of effects, this type of sim, is not something that you can create with the smoke solver by default. You cannot have this kind of expansion happening in 2 frames. Okay, you cannot have a source that expands to this, and then and then this from here to here, and then wow, that's a huge. You can see another explosion as well. If we had a slow-mo camera, we would probably see much more information happening here, but we don't generally observe that kind of details. So even just looking at a change between these frames gives our brain the illusion that the correct illusion of what's happening. And this is basically what happens in most of the explosions. There is a huge chemical reaction that causes a lot of expansion in just a couple of frames, and then everything after that is a continuation of what's happening. Now it depends on the scale, depends on the type of chemical that the explosion is made of. The result can vary drastically. And in this case, you can see the smoke, for example. There's not so much smoke created here, and it's all being lifted up. Now the reason it goes up is because it's very hot. Smoke doesn't just rise for no reason. If this was not a hot smoke, it will take a lot longer for it to rise. And even though we don't see the temperature, we don't see the heat in here, it's still hot smoke that causes it to rise. And then we have the fire burning in there. So this is where the pyro solver comes in. And what Side Effects did is they created a pyro solver. And what this pyro solver has, it has a combustion model. And what the combustion model tries to do is it's going to try and recreate this kind of expansion. So you give it basically a fuel, and you tell it how much it ignites and how much gas it releases, and then from that information it decides how much it expands. It decides how much to grow, and then it gives you the result back. So you get expansion, you will get temperature, and you get heat. And if we create a pyro solver, there's this tab here called combustion, and I believe it's on by default. So if I hit tab and type in a pyro solver, you can see there's this tab here. It's on by default, and this is where we control the expansion that happens in the explosion. Okay, and then from that expansion, it's going to also create a new smoke or more density, basically. And then there's a fuel field, there's a heat field, there's a burn field, there's a temperature field, and a density field. And all of these are interacting together to create the expansion needed for the explosion. And I'm gonna put this aside, the combustion tab, for a second, and I want to take a look at the shape tab here. And what this is it's basically all the modifiers that we talked about, except the sharpening. Yeah, we'll talk about that later, but it basically sharpens the density field. And what this tab is it's all the microsolvers that we talked about all grouped together, and when you tick on one of them it becomes active, and then you have all the controls for it here. So if I tick on the turbulence and go under the turbulence tab, you can see it's exactly this tab here. And what side effects did is they took all those and said, okay, this is what people will be using most likely to break the to create more interesting shapes, so let's add them in the solver by default. But these are nothing more than what we did here. So this is exactly the same section, and then all the other options are very similar to the default options in the settings. And then relationship is the same. Actually, let me create a smoke solver. So relationship is actually the same as in the one in the smoke solver. The advanced tab is the same as the advanced tab in the smoke solver as well. And the only difference is this combustion model. This guy we can also ignore because we can manually add in our stuff, and the only new addition is here. So what the pyro solver really is, it's a smoke solver with a combustion model that can cause the smoke to expand, plus all the modifiers that we learned previously. So I'm gonna allow editing this, and I will try and find something quickly. So this is where advect fuel, modulate heat. This is the combustion model, okay? And you can see here, if we expand this, you can see it's a smoke solver build 2 underscore build 2. So it's probably a different version to account for some new features that they needed here, but it's basically a smoke solver with some extension. And this is what we're going to be doing after we understand why we want this. We're going to be building a new solver that has a custom combustion model and many other things that is based off the smoke solver as well. So we're going to use this as the base because it's a great solver, and we only need the advection of the various fields and to solve the pressure and the divergence. And these are the nodes that we talked about: the turbulence, the shred, the confinement, disturbance. And then this is the combustion model that it's going to take the ignition and the various fields that we're going to learn about to create the expansion that we need. And if I select this, you can see it's this node here. It's called gas combustion, and internally it's an HGA as well. It's a subnetwork that has various microsolvers, and everything is being computed here. So all these nodes are doing, they're deciding how to burn the heat and how to convert that into how to burn the fuel, how to convert that into heat and temperature, and then how much to expand the fluid, the smoke sim. And this is what is responsible for that. And then all the other stuff is just making sure that this data is being plugged through the render correctly. But the main thing for the pyro solver is this guy. This is the only new feature, the only new node that we need to care about. And then what we're going to be doing in the next video is we're going to switch this emission to have a pyroclastic, to create an explosion, and then we're going to start tweaking that to create the nuclear explosion that I showed in the first video. Thank you guys for watching, and see you in a bit. Bye-bye.